All right, let's talk about the unsung heroes of all your favorite gadgets. We're talking about resistance, or as I like to call them, the traffic cops of the electronics world.
I mean, think about it for a second. It's a real question. You've got all this power coming from the wall or a battery. So what's stopping your phone or your PlayStation controller from just, poof, frying in a little puff of smoke?
Well, the answer is this tiny little component called a resistor. Its entire job is to slow things down, to control the flow of electricity. It really is like a traffic cop for electrons, telling them, hey, slow down, just to make sure everything runs safely and smoothly.
So how in the world does this little component know exactly how much traffic to let through? Well, it all comes down to a really simple, kind of beautiful little rule. And that rule is Ohm's law. Now, it might look like scary math, but I promise it's super simple. You've got voltage, or V, which is the push from your battery. You've got current, I, which is the actual flow of electrons. And then there's our hero, resistance, R. That's the restriction, and we measure it in a unit called ohms. That's that cool little omega symbol you see there.
So here's the key thing to get. It's a balancing act. If you increase the resistance, make it harder for those electrons to get through, then the current has to go down. It's kind of like squeezing a garden hose, right? The tighter you squeeze it, the less water can get through. It's really as simple as that.
Okay, but here's where it gets interesting. Not all resistors are created equal. Let's meet the three main players you'll run into, our resistor heroes, each with its own special superpower.
First up, we've got the most common hero of them all. Seriously, you'll find this guy on pretty much every circuit board ever made. This is the fixed resistor, and its superpower is just being incredibly consistent. Its resistance value is set once and it never ever changes. It's the ultimate reliable workhorse, the stabilizer that protects all the sensitive parts by making sure the current is always steady and predictable.
But what if you want to be in control? Well, our next hero is all about giving you the power. Meet the variable resistor. You might also know it as a potentiometer.
So how does this one work? Well, inside there's a special track. And as you turn the knob, a little part called a wiper moves along that track, changing the resistance as it goes. And trust me, you've used this hero thousands of times. Every time you turn a volume knob or use a light dimmer switch, that's a variable resistor in action.
And for our final hero, this is the smart one. This is the one that can actually see and react to the world around it.
This is the light-dependent resistor, or LDR for short. In the dark, its resistance is super high. But the moment light hits it, its resistance just plummets. This little bit of magic allows the circuit to react to its environment. You know the sensor that makes streetlights turn on automatically when it gets dark? Yep, that's our LDR hero at work.
Okay, that's a lot of theory. It's cool, but let's actually see how these heroes do their thing in the real world. Let's imagine a simple challenge with 3 different LEDs. All right, path 1. We take our reliable fixed resistor and hook it up to an LED and a battery. So what happens? You get a perfect, steady, bright glow. The resistor is doing its job, protecting that LED by giving it just the right amount of current. No more, no less.
Now for path 2, with our variable resistor. We hook it up, and this time, as we turn that knob, we're changing the resistance in real time. And what do we see? The LED smoothly fades from super bright all the way down to dark. We are in direct control of the power.
And for the grand finale, path 3 with our smart LDR. Now, if you cover the sensor with your finger, you create a shadow. The resistance shoots up and the LED gets dim. But then you shine a light on it, the resistance drops, current rushes through, and the LED glows brightly. How cool is that? The circuit is literally responding to the world around it.
Okay, so we've covered the theory, we've seen them in action. Let's tie this all together with one last, really helpful analogy. Just imagine that an electrical circuit is like a giant water slide.
In our water part, the fixed resistor is like a part of the slide that's always narrow, making sure everyone goes at a safe, constant speed. The variable resistor? That's like an adjustable gate that you can open or close to control how much water or how many people flow through. And the LDR? Oh, that's a magic slide. It actually gets wider when it's sunny so you can go faster, and then gets narrower when it's dark to slow you down.
So at the end of the day, that's what this is all about. Resistors might be tiny and easy to overlook, but they are absolutely essential. They are the unsung heroes, the silent guardians, quietly managing the flow of everything to keep our entire digital world running. So, the next time you dim a light or turn up the volume on your speakers, you'll know there's a tiny hero inside doing all the hard work.
And that just leaves one last question to chew on. What other invisible components are out there absolutely essential to the technology you use every single day? Thanks for joining me.